guys. In this video, we are going to study the basic requirements of a transducer in a measurement system. We will see the various points of the requirements of the transducer. So let us start with our topic. We know that a transducer is a device which converts a non-electrical quantity into an electrical quantity. So when a transducer is used in a measurement system, its main function is to convert the non-electrical quantity into an electrical quantity, and it should do that conversions in the specified limits for that input quantity only. Okay, so there are various requirements which a transducer should meet when it is being used in a measurement system for doing that conversion. So let us see that what are these basic requirements which are expected from a transducer or from a basic transducer. Okay, first requirement is range. If we define range of an instrument, it is defined as the maximum and the minimum value of the input quantity that can be measured from that instrument. Suppose that we are having a thermometer. The minimum temperature that can be measured from a thermometer is 0 degrees Celsius, and the maximum temperature that can be measured from this thermometer is 200 degrees Celsius. So the range of this thermometer is 0 to 200 degree Celsius. So if we define the range of a transducer, it is the maximum and the minimum limits of operation of a transducer. So the physical quantity or the input quantity which is being measured by the transducer should be capable of operating at the minimum and the maximum value of that parameter. Okay, means in the entire range in which this input quantity is available, the transducer must be operable over the entire range. Okay, so first requirement which is expected from a transducer is that transducer must be operable over the minimum and maximum values of the parameters to be measured. Second is accuracy. Now, if we define accuracy, it is the closeness of the measured value to the true value of the quantity. True value means it is the actual value of the quantity, and measured value means the value which is measured by the instrument. Okay, so we are having two values for the quantity. One is the true value and one is the measured value. So the transducer, it should be accurate, means the value which is measured by the transducer, it should be very close to the true value. Okay, so when a transducer is doing the conversion from a non-electrical to electrical quantity, the non-electrical quantity, its magnitude should be close to the electrical quantity, means there should be conformity between the indicated value and the accepted value. Indicated value means the measured value and accepted value means the true value or the actual value of the quantity. So we can say that the transducer should be accurate in its measurements. Third is repeatability. Repeatability means when we are using the transducer for doing the same measurements again and again, the output value of the transducer, it should be close to all the measurements. Okay, means all the measurements, they should give the values which are very close to each other, means the output is repeating itself in the measurements. So transducer, it should have a good repeatability. So repeatability is defined as the closeness of the output value among a number of consecutive measurements for the same value of the input. Means that we are applying the same input and again we are measuring the output value. So how close the output values are with each other, that is called the repeatability. So what is expected from a transducer, that it should have a better repeatability. Next requirement is sensitivity. Sensitivity is defined as the ratio of the change in output to the change in input. So sensitivity is defined as the ratio of change in output to the change in input. Means if we are making any changes in the input, the change in output should be in proportion to that. Okay, so if we are changing the input, like for by 5 units we are changing the input quantity, so same change of 5 units will be seen in the output quantity also. So it is expected from a transducer, it should have a good sensitivity. Whenever we are making variations in the input, same variation should be seen in the output also. So it should be the transducer should have be highly sensitive for better resolution of the system. Now next requirement is environmental effects. Environmental effects includes the influence of temperature, pressure, humidity over the instruments. So the transducer, it should be less affected due to these environmental conditions, so that it can act very versatile and very accurately in these environmental conditions. So the influence of these environmental factors over the transducer, it should be minimal. So The environmental effects like the temperature, acceleration, shock, vibration, corrosion, these environmental factors should not affect the performance of a transducer. Next is noise. Not only the environmental factors but also the noise should not affect the output of the transducers. The output of the transducer should not be contaminated by the unwanted signals or the undesirable signals, which are called the noise. Next requirement from a transducer is the loading effect. Loading effect occurs whenever the input and the output impedances of a transducer stage or of a stage in a system, it is different. Okay, means there is no matching between the input and the output impedance. In that case, loading effect occurs. Okay, so if we are having high output impedance of the transducer, this loading effect can be reduced. So loading effect, so for a transducer, the loading effect, it is determined by the mass, exterior size and the geometric configuration of the transducer. So a transducer should have a very less loading effect on the system in which it is used. So whenever a transducer is used in a measurement system, it should have very less loading effect on the other instruments or on the other devices which are used in the system, because the transducer, it has the property that it can absorb some energy because of these factors, so it has very less loading effect. Now, as I have said that if we want to reduce the loading effect, then the output impedance of the transducer, it should be very high and it should match with the input impedance of the other devices. So here the output impedance, it should be matched. Measuring system. Okay, it should match with the input impedance of the rest of the devices in the measuring system. Next characteristic is the power requirements. Whenever any instrument is used in a system, it is required that instrument, it should use very less power. Okay, very less power consumption should be done by the instrument. So the same requirement is for the transducer also, that the transducer, it should be capable of consuming very less power. Now in transducer there are two type of transducer which are called the active and passive transducer. Active transducer, they generate the power by itself, means they are the self generating transducers. The power which is required for the conversion process, it is provided by the transducer itself, whereas the passive transducer, which are also called the externally powered transducers, they require an auxiliary source which will provide it the power. So here the proper voltage should be applied for the externally excited transducers so that they can work properly. Okay, so the input voltage which is required for the conversion process, that should be properly given to these externally excited transducers. Next requirement is frequency response. Now, if we talk about the frequency response of a transducer, the transducer should have an accurate response to the maximum rate of change of the system. Okay, means that when we are changing the output to a maximum value, means we are making a maximum change in the output of the system, then the transducer, it should give an accurate response to that change. Okay, the change of the output with the input frequency, it should be flat over the measurement range. Okay, so this is the basic requirement which is expected from a transducer. Next is linearity. Linearity defines the input output characteristics, means when we are changing the input by some value, then same amount of change is being taken in the output. So if we draw a graph for this, suppose this is our input, and this input, when we are changing the input, the output is also changing linearly with it. Okay, so same amount of change has been taken in the input and we have got a linear relationship between these two. So the transducer, it is also expected that the input and output characteristics of the transducer or input output relation of the transducer, it should be linear. Next is rigidness. Now, if a transducer is used in an application where overloading is being done, means that the input is being exceeded, is exceeding its value. So, under that overloading condition, also the transducer, it should be accurate enough. So, that is called the rigidness of the transducer. That the transducer, it should be rigid enough to withstand the overloads. Now, next requirement is the quality of the output signal, it should be good enough from the transducer. It should not be affected by the noise and the environmental factors. So it is required from a transducer that it should give an output signal which is of high quality. So it is required that the output signal, it should be have good quality, and it should be possible only when the ratio of the signal to the noise is very high. Signal to noise ratio is very high, and also the amplitude of the output signal is high. Then the output signal from the transducer, it will be of a very high quality. Another requirement is high reliability and stability. The transducer, when it is used in a measurement system, it should give minimum error in the measurement. So it should be reliable and it should be stable in all the environmental conditions. Whenever in all the conditions wherever it is used, it should give a stable response. Also, it is expected that a transducer, it should give a good dynamic response. Dynamic response is the response of the transducer, which is a function of time. Means as the time is increasing, the response of the transducer, it should be very good. It should not decay its quality, or it should not diminishes or get to a minimum value as the time changes. Means the quality or the performance of the transducer, it should not degrade with time. It should give a good dynamic response over all the time of its operation. Another requirements are also there for a transducer, that when it is used in an application, a transducer, it should have a very less in size. Its size should be small, its weight should be less, it should be cheap, and it can be easily transportable from one place to another. Okay, so these are the basic requirements which are expected from a transducer when it is used in a measurement system. And here in this video, we have studied some of these basic requirements of a transducer. So I hope that this topic, it is now clear to you. Thank you.